Hello, I'm Jeffrey Goldberg from 1Password, and I'm here to talk about something that we did a couple years ago. It was a password cracking competition, um, and as I said, it was a couple years ago. Uh, so this is a belated report on it, but here it is anyway. People have heard bits and pieces about it here. So really the question that we were after, the reason that we ran this whole thing in the first place was uh, to help us answer the question that people asked us, which was how strong should your master password be? And the old answer, that we gave before this was that your master password should be the strongest you can reasonably and reliably remember and use. And after this, the answer was it depends, but generally the strongest you can reasonably and reliably remember and use. And you might think that it really wasn't all that wise to give out about $30,000 in prizes just to add the it depends, uh, which of course it depends is the answer to almost any security question. Um, but before I get into the competition and what we learned from it, I do need to explain something that's a little bit unusual about 1Password. It's a bit weird um, in that all of the computation and key derivation is performed client side, and client side, the user's master password is combined with a high entropy thing. We call it the secret key, which is also stored client side. And given the way that these are combined together in the key derivation, that means that what we have server side cannot be cracked even if somebody has a terrible master password, because the attacker would need to guess this high entropy secret key. So the role of the master password, of the 1Password master password, is thus to defend against an attacker who gets user data from the user's device. That's the threat that we're after, and this is the situation in which the user's master password is pretty much their weakest point. So just adding to this, there's a paper a while back that talked about circumstances in which you don't care about the strength of a password, not a password manager password, but you don't care about the strength of a password when unless it is so weak that it can be guessed through an online attack, or if you can manage to get it so it's completely uncrackable. And the argument is for a particular class of problems, the strength of the master password in between doesn't matter. With something like a password manager, the opposite is the case. Again, consider the attacker who gets a victim's password manager data, and in our case the secret key, from the user's own device. How long the victim has to really start changing their passwords that are stored in their password manager depends crucially on the strength of their master password. Whether it's going to take days, weeks, months, years, decades to crack matters a great deal in these circumstances. So we really do have to care about these things. I'm going to skip ahead. I've got way too many slides. But the passwords that we were particularly interested in were these 3-word passwords from our password generator, which were about 42.5 bits. And the question of how long does it take to crack is pretty much the wrong question, as anyone involved in cracking knows. And a much more useful question is how much does it cost to crack? So we wanted to try to design a contest that would help us understand how much it would cost for someone to crack those passwords. And we found that for those it cost about 4,300 US dollars, and that translates out to about 6 US dollars per 2 to the 32 guesses. So there you go. There's your spoiler. You don't need to listen anymore. Okay, there were lots of things that we wanted in designing the contest. We'd never designed a contest before. And you can read about those at your leisure. Also, some of the details about how we set the whole thing up. This is all publicly available in links that I'll give you. You know, everything was done very openly, transparently. One thing I will say is that when we generated the challenges, we chose to keep a copy of the actual passwords that the challenges were created from, for a reason that turned out not to apply, but it turned out to be very good in the long run that we did keep these. Okay, so when we strip out all of the irrelevant complications of the 1Password KDF, and we strip out concerns about the secret key, the guts that we needed to check is PBKDF is 100,000 rounds of PBKDF2 using HMAC SHA-256, and we posted 7 challenges. And they looked something like this, with assault and the derived key, and the goal was to find out what password they were generated from. We also showed how these passwords were generated using our password generator, and gave the list so that the passwords were generated uniformly. Okay. We also published a couple of test things so people could test their configurations and test that what we said worked. So there's really all the same, except also actually includes the answer. Okay. The tricky part was getting the incentives right for the contest. If we'd known how much it would have cost to crack these things, then we could have gotten the incentives. We could have set the incentives a lot better. If we'd known how much it would cost to crack these things, then we wouldn't have really needed to run the contest in the first place. But the sort of initial guess going in was somewhere between $500 and $5,000, basically. A range of 4 bits, you know, of 4 doublings. All of the money amounts that I talk about are US dollars, 2018 US dollars. Anyway, so when we first offered this, we offered these prizes. 496 for first place winner. And it quickly became apparent from people looking at the contest and starting things up that this really wasn't going to pay for people's efforts. So on June 11th, we doubled the prizes and we added a 4th place one. And on July 26, 2018, we doubled again. So now the prizes are 4 times our initial thing. Um, Quadrupling the prizes still wasn't enough to really make it worthwhile. We're getting a lot of feedback from participants, and they were reporting on their efforts. So we needed to come up with a system of hints. The hints needed to be uniform and measurable, and not bias things in certain ways. And I'm gonna just skip through this, but it did turn out to be really useful that we kept a copy of the solutions. Otherwise, we never would have been able to generate the hints. But the guts of it were that the hints were the first hint was a leading bit of a fast hash of the password. Leading, there you go. There's a slight problem in that I was at my mountain hideout in Colorado. The external medium that I'd stored the heavily encrypted solutions file on was in Plano, Texas, and I had places to go in between. Anyway, there's a timeline for when we discussed published details about the hints. And we did the first bit on August 23rd, and on September 24th, a month later, we did a second bit. And so we have now cut down the search space, the remaining search space that people had to go through, by 4, halved and halved again. And that's, after that, we can skip that. After that is when we started seeing results. So middle of October, and then November. The first 3 prizes went to variants of the same team. They kind of kept on adding people to the team, to their team after each win. And 4th place, and I would say that that team of very sophisticated and professional password crackers kindly stepped aside to let some of the people who are new to password cracking still compete for 4th place. So it was people who'd never done password cracking before who did 4th place. Okay. And one of the crucial criteria to actually get paid your winnings was to do a write-up of your experiences, your estimates of your costs during the whole thing, because again, we wanted to know how much it costs for somebody who's incentivized to crack these things to crack them. And the write-ups are absolutely fascinating. Please go and read them. Anyway, there are a couple ways from the various write-ups to try to get an estimate of the costs. Came up with 4,000 something US dollars is what it would take, is average cost to crack one of those 3-word passwords without hints. And then working from there, we get to the $6 per 2 to the 32-bit guesses. And again, this is all PBKDF2, so 10,000 rounds of PBKDF2 and HMAC 256. Here's a cool table that you can go and look at by following links that are available in the slides of what the costs using this KDF would be for different sorts of things that are that the 1Password password generator could generate. I should warn you that not all of the features that are used here are actually exposed to users in configuring the generator, um, uh, but it's actually built in there underlyingly. So, uh, 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 short things to highlight is again $4,300 for these 3-word ones, and for the 4-word one, it's about $80 million. So adding a single word and using our generator makes a really big difference. Okay, there were a number of things that I got wrong in this. There are a couple technical things that, if you go back over some of the skipped slides, you'll see um, with doing the hints. But mostly, what I got wrong were things having to do with setting the incentives. I was aware of these things, but did not fully take them into account. And so one of them, of course, is pricing this so that it's worthwhile for people to participate and compete, knowing that they might not win. So making the thing profitable for the winner is fine and necessary, but you need to make it more profitable. You need to make it a big enough win that people will, in a sense, gamble on it, knowing that they're competing with others. So and this was actually a reason. This is something. We were getting this from feedback during the discussion. I've got links to that whole online discussion where this thing was discussed. Again, for anyone interested in cracking or some of the choices that we made, that's a really good place to look. Another thing with incentives, and this is harder. Largely because I don't know anything about cryptocurrency mining. But it's the notion of opportunity costs. So even if you deem that it is profitable for you to participate, and factoring in the fact that you might not win, while it can be profitable, could you do something better with your time and equipment and knowledge than dedicating it to this effort? So this is something known as opportunity costs, is that when you choose to dedicate resources for one thing, it means that you're not dedicating those same resources to something else that might be more valuable. And so the difference in the valuables with that is a cost. And so of course, there were people who did, people new to password cracking, who did turn over cryptocurrency rigs to these attempts. And because of these two failures at the beginning, even though in the end, after the hints and after the twice doubling of the prizes, it was worthwhile, because it wasn't worthwhile, or may not have appeared worthwhile at the very beginning to potential participants, we didn't get that many experienced password crackers in. We had the winning team, and we had a couple others who played around for a bit. But it would have been nice to have had multiple experienced teams competing with each other. And instead, I suspect that they looked at it, they looked at their chances, they looked at the costs, they looked at the opportunity costs, and decided not to participate. But a huge thanks to those who did and stuck with it. And And again, we've learned quite a bit. Our answer is still it depends, but we now have something more concrete to tell users, and to help users consider their own threats, and whether an attacker who gets a hold of their data is going to put in $4,000 worth of efforts. And that's it. I will take questions at this point.